So this is the output characteristics of a transistor when it is biased in a common emitter mode. So in common emitter mode, the output current is collector current IC and output voltage is voltage across collector and emitter, and the input current is the base current, that is IB. So you see, when the base current is 0, you have the collector current that is also 0 and is ideally, and the small current that is being shown here, that is due to the reverse leakage current in the collector emitter junction. So that current only flows, but due to the IB there is no collector current flowing, and essentially you say that the transistor operates in the cutoff region, and the biasing condition for the cutoff region is that both the junctions, that is base emitter junction and the collector emitter junction, they are reverse biased. On the other hand, you have a saturation region where both base emitter junction and collector emitter junction are forward biased, and you have a large amount of collector current that is flowing. Third region is the active region, which is unshaded in the middle, and for every value of base current, that is input current, you have a curves of the output current which is constant, and this condition is when your base emitter junction is forward bias and the collector emitter junction is reverse bias for the NPN or PNP transistor. So remember, this is an output characteristics for a common emitter silicon bipolar junction transistor. What would be the output characteristics for the common base mode and the common collector mode? That's an exercise for you.